Let's have a look at the RL low-pass filter now. An RL low-pass filter is designed to allow low-frequency signals to pass through while attenuating high-frequency signals. In this configuration, a resistor and an inductor form a voltage divider. At low frequencies, the inductor exhibits low impedance, so most of the input voltage appears across the resistor to the output. As the frequency increases, the inductor's impedance rises, and that diverts more voltage away from the resistor and thereby reducing the output. This gradual transition between the pass band and the stop band is characterized by the filter's cutoff frequency. Here is a simple schematic of an RL low-pass filter. The behavior of the RL low-pass filter can be described by its transfer function, which is given by this formula here. By substituting the complex frequency S with J times omega, where omega is the angular frequency in radians per second, the transfer function becomes this. The magnitude of this transfer function, which represents the filter's frequency response, is given by this formula. At low frequencies, where omega times L is much smaller than R, the magnitude is nearly 1, and that means that the output closely follows the input. As omega increases, the term omega times L squared becomes dominant and the magnitude decreases. The cutoff frequency, defined as the frequency at which the output falls to 1 divided by square root of 2, which is approximately minus 3 decibels, is calculated by this formula here. So Fc is R divided by 2 times pi times L. This model is derived using the voltage division principle, as I mentioned earlier, where the inductor's impedance, J omega L, increases with frequency, thereby reducing the voltage across the resistor. This Python script demonstrates how to plot the frequency response of an RL low-pass filter and marks the cutoff frequency of the plot. When you execute this script, it produces a plot that displays how the RL low-pass filter maintains a high output at low frequencies and attenuates the signal as the frequency increases, with the cutoff frequency clearly marked. Now let's have a look at the key takeaways from this lecture. In an RL low-pass filter, the resistor and inductor form a voltage divider. Low frequencies see a low impedance in the inductor, resulting in most of the input voltage being dropped across the resistor. Here is the filter's transfer function, which determines how the output varies with frequency. And here is the frequency response, or the magnitude function, which shows that at low frequencies, the output is nearly equal to the input, while at high frequencies, the output is reduced. Here is the formula for the cutoff frequency, which defines the transition between the pass band and the stop band, serving as the key parameter in the filter's performance.